This is now midterm exam review. We are now in session. So let us start. First problem here, factor completely the quantity x squared plus 2x minus 1 squared minus 4. So in here, obviously, you immediately see that this is a difference of two squares type of expression. So we can easily apply the formula or the identity for the difference of two squares. So we recall if you have a squared minus b squared, this is simply a minus b times a plus b. Okay? So in this case, this is our a here, and in here, this is our b squared. Okay? So if we include the square for the a, so let's extend this guy. So this is your a squared, which means that if we are going to factor this expression, we will have uh, quantity x squared plus 2x minus 1, okay? And then minus 2 times quantity x squared plus 2x minus 1 plus 2, okay? So this is a minus b times a plus b. And then we simplify this. We will have quantity x squared plus 2x, and then you have here minus 1 minus 2, so we'll get minus 3 there. And in here, we have x squared plus 2x minus 1 plus 2, so that becomes plus 1. Okay? And notice for this guy here, okay, for this guy here, this is a perfect square trinomial. So let me recall that. You have a plus b quantity squared. This is equal to a squared plus 2ab plus b squared. And if we have minus a minus b squared, this is a squared minus 2ab plus b squared. So recognize that this expression here, okay, is of the form a plus b quantity squared, right? And then for this guy here, you can factor this, okay? Um, Let us factor this guy here, okay? So let us factor this guy here if we can, okay? So just part of your solution, let me just put it here. You have your x squared plus 2x minus 3. So your b here, this is equal to 2. Your c here, this is equal to negative 3. So you need to find a, b, okay, such that a times b, this is equal to negative 3, and a plus b, this is equal to 2. Okay, so you have here your c, this is negative 3. Okay, and then here you have your a, b, and then this is your a plus b. Okay, so this is negative 3, and let's do this immediately. We can try positive 3 and then minus 1. So notice 3 times negative 1, that's negative 3. Okay, 3 times negative 1, that's negative 3. So this is what we want. C equals AB. 3 times negative 1, that's negative 3. And if you add them, you will get 2 in here, which means that this first factor here can still be factored into x plus 3 times x minus 1. Okay? And then, for the second factor, we apply the formula here. It's a perfect square trinomial. So we use this formula here, and we will get x plus 1 quantity squared. So this is the factored form of the original expression here. Okay? Next problem. We would like to factor completely 5x cubed plus 3x squared minus 20x minus 12. So this is a cubic expression. So maybe we can use grouping, okay? Factoring by grouping. And I hope we are lucky if we use that one. So what we can do is to group these guys here and also these guys here. So let's just put the parentheses and the grouping symbols. You have quantity 5x cubed plus 3x squared. And then you have minus 20x minus 12. And let us factor that minus so that we will have minus quantity. The one inside the parentheses becomes 20x plus 12. So take note of the change of sign in here. Okay? And then on the first addend here, for this guy here, we can factor out x squared. So if we factored out x squared, we will have x squared. And then inside the parentheses, we'll just get 5x plus 3. And then minus. And then here you have 20x plus 12. Okay? 4 is a common factor. So we can factor out 4. And what's left inside is this expression 5x plus 3. So we are lucky in a sense because this guy here and this guy here, it's now a common factor, which means we can factor that out. And this expression here can now be written as, so you will get x squared minus 4 times 5x plus 3. Okay? But this guy here, this is still of the form x squared minus a squared. So difference of two squares. So we can still factor this into x minus 2 times x plus 2. And then we have the 5x plus 3 there. So this is the final expression or the final factored form of the original expression here.
Sure.
Okay? Yes, question.
Where it says x squared open bracket 5x plus 3 close bracket, how come there's on top of that there's a 5x to the power 3 plus 3x squared? What happened to the x cube on
Yeah,
the
we
front?
factored out this. We factored out the x squared.
But wasn't the x squared with the 3?
No, when you factor, what happens when you have AB plus AC? When you factor A, what's left inside? B plus C.
Oh, okay.
That's
Thank
what
you,
we
sir.
did in here. So your x cube here, okay? Your x cube here, you can write it as x squared times x, correct? So you
Yeah.
can, your x squared is a common factor. You factor that out. All right.
Okay. Thank you, sir. I got it now.
You're welcome. So other questions? All right, so let's proceed to our next problem. Factor completely 3x cubed plus 2x squared minus 27x minus 18. So very much similar to the previous example in here. Okay, so we'll do the same solution. Okay, so we group these two guys here. We also group these two guys here. So let's just put the grouping symbols first. We will have quantity 3x cubed plus 2x squared. And then we factor again the negative. Don't forget that. So minus here. And then we will have 27x plus 18. Okay? 27x plus 18. And then we will have x squared times 3x plus 2. Then minus. And then for this part, we will be able to factor out 9. If we factored out 9, what will remain inside is the expression 3x plus 2. Then again, this guy here and this guy here, it's a common factor of these two expressions. So we can factor that out. We can have 3x plus 2, and the other expressions, okay, the other expression here and here, we'll have x squared minus 9. And again, for this guy, this is difference of two squares. 9, it's equal to 3 squared. So we can use the difference of two squares identity that we learned. So we will have here 3x plus 2. And then for this x squared minus 9, we'll get x minus 3, x plus 3. So this is the final expression. Okay? So notice, in this solution, I put this common factor here and here on the left side of x squared minus 9. In here, this expression here, this common factor here, I put it on the right side of the other guys in here. Okay? So it doesn't matter whether you put it on the left or on the right. So you still get the same or the correct answer. Okay? Note that multiplication is commutative. AB, that's equal to BA. Okay? If A and B are real numbers. Questions? Okay? Next. Rationalize the denominator and then simplify. So we have here 2 square root of 5 minus 5 square root of 2 all over 3 plus square root of 10. So we have the denominator here with a radical, and it's 3 plus square root of 10. So we need to multiply both the numerator and denominator by the conjugate of this expression here. So we have the plus here, we need the minus counterpart. So we multiply both the numerator and denominator by 3 minus square root of 10. Okay? And of course, for the denominator, it just, or it becomes, you will have here 3 squared minus square root of 10 squared. That's for the denominator. Let me put the solution below. So I will have here 3 squared minus square root of 10 squared. For the numerator, we apply FOIL method. So let me just write the FOIL method. Okay? So if you have A plus B and then B or C plus D. So the FOIL method will just have here first, sorry, that should be first here, and then outer here, okay? And then the inner, and then the last, okay? Or any combination of this FOIL here, okay? So basically, it's just distributive law applied a lot of times. So for the first one, this guy here multiplied to this guy. So we will have 2 square root of 5 times 3. That becomes 6 square root of 5. And then this guy here multiplied to this guy. So 2 square root of 5 minus square root of 10 will have minus 2 square root of 5 times square root of 10. And then here you have minus 5 square root of 2 multiplied to 3. So we will have minus 15 square root of 2. And then finally, we have 5 square root of 2 times, sorry, it's negative 5 square root of 2 times negative square root of 10. So it becomes plus 5 square root of 2 square root of 10. Okay? And then we recall that square root of 10, this is just square root of 2 times 5. Okay? Let me write it this way. Okay? And this is equal to square root of 2 times square root of 5. Okay? So what will happen to this? We use this guy here and replace this square root of 10 here and also this square root of 10 here. So we will have in the numerator, we have this square root, 6 square root of 5, and then 2 square root of 5 square root of 10. So there will be square root of 5 in here and another square root of 5 in here. That becomes 5, which means we will have here minus 10 square root of 2. Then we have minus 15 square root of 2. And then for this guy here, okay, again, we have here square root of 2 and the square root of 2 in here. So we have square root of 2 times square root of 2, so that's just times 2. So 5 times 2. So we will have plus 5 times 2, that's 10. And we have here square root of 5. And then on the denominator, we have 9 minus 10. And then if we simplify the numerator, what do we get? We'll just have 16 square root of 5 minus 25 square root of 2 divided by negative 1. Or we can write this as 25 square root of 2 minus 16 square root of 5. So this is the final expression. Okay? Let's now have the following problem here. Perform the indicated operations. We have 2x squared plus 5x plus 3 all over x times 2x minus 3 divided by 2x squared minus x minus 6 all over 2x squared minus 3x. So what we do first here and second is to factor out all expressions that we can factor and also convert this division into multiplication, which means if we do that, we will have to get the reciprocal of this. Okay? So this guy here, let me just write it here. So I'll have a lot of space. We can factor 2x squared plus 5x plus 3. Okay, let's do those factoring methods. Let's use the general way of factoring, actually the way of factoring general quadratic expression. So remember your ax squared plus bx plus c. So to factor this, if possible, we will need to find small a, small b, such that uh, the product small a, small b, this is capital A times capital C, and then the sum small a plus small b, this is capital B. Okay, so we have here a c. In the case here of 2x squared plus 5x plus 3. So AC, that's equal to 6. Okay. B, that's equal to 5. So you have here AC, this is small a, small b. We have here A, we have here B, and then we need A plus B, this is capital B. So all throughout your AC, it's just your 6. Then we think of factors, A and B, so that the product AB is equal to 6. Let's use 3 and 2. And we check that this 3 plus 2 here, this is equal to 5, which is what we desired. Which means what? This means your x squared, or your 2x squared plus 5x plus 3, we rewrite this as 2x squared plus 2x plus 3x plus 3. And from here, we do the grouping to completely factor the expression. So we will have here, we can factor out 2x, and we'll be left with x plus 1. In here, on the other side, we can factor out 3, and we'll be left with x plus 1 again. And then we can factor out x plus 1 because it's now a common um, factor of these two addends here. Which means in the numerator, for the first factor there, or for the first expression there, so this guy here, we can write it as 2x plus 3 times x plus 1. Denominator, it's factored already. So we'll just copy it. X times 2x minus 3. And then like I said, division will convert it to multiplication. So we have to get the reciprocal of this. For the expression here, 2x squared minus 3x, that's easily factorable. Okay, so 2x squared minus 3x, we can easily factor out x. So we will have x times 2x minus 3. So we have here x times 2x minus 3. And then for the last guy here, we can do the same thing, the same the same factoring method as in this guy here. Okay, so let's just write that. This time our AC, so you have here 2x squared minus x minus 6. So AC, this is 2 times negative 6, this is equal to negative 12. Then we have your A here, we have your B here. Capital AC, it should be small a times small b. And then here you have, on the last column, you have a plus b. This is equal to capital B, and you want this to be negative 1. So here you have negative 12. And let's choose the correct pairing immediately. So this is negative 4 and 3. So negative 4 times 3, that's 12. That's negative 12, I mean. And then negative 4 plus 3, that's negative 1. Which means that we can now have 2x squared minus 3x minus, minus x minus 6. We can rewrite this as 2x squared minus 4x plus 3x minus 6. We group this together and also this together. In the first group, we can factor out 2x. And then what will remain inside is the expression x minus 2. On the second group, we can factor out 3 and we'll have x minus 2 again. Which means we can now factor the expression 2x squared minus x minus 6 into 2x plus 3 times x minus 2. So in here, everything is in factored form. We can now do our cancellation. So this 2x plus 3 can cancel this 2x plus 3 here. This x here can cancel this. And then the 2x minus 3 here can cancel this guy here. And what's left is the expression x plus 1 divided by x minus 2. Okay? So this is the complete details of this of the solution of this problem. If you can factor these guys here immediately, these guys here or these guys here, okay, it's totally fine. Okay, a lot of students can factor that without doing this general this solution in here. Okay, so you can do that. Just make sure that you are writing the correct factor. Okay, otherwise you won't get anything. Okay, questions? Next problem, perform the indicated operations. So we have here y minus y over y minus 2 minus y over y squared minus 3y plus 2. Okay? So we are subtracting two rational expressions. Denominators are not the same, so we can do LCD method. Okay? So for this, we can write this as y over y minus 2 minus y over y squared minus 3y plus 2. We'll factor that. Okay? So I'll skip the details for this part. Y squared minus 3y plus 2. So practice your factoring. You should be able to factor that expression into y minus 2, y minus 3, y minus 1. Okay? And then, well, first observe also that your y here is a common factor. So you can actually factor it immediately. So if we do that, okay, if we do that, you'll just have y times the quantity of 1 over y minus 2 And then you have here minus 1 over y minus 2 y minus 1. Okay? And then you can now combine these two parts here. So if we do that, you will have y still outside. LCD, it's y minus 2 times y minus 1. Okay? And then for this guy here, we only have y minus 2, but we need the y minus 1, so we multiply this y minus 1 in the numerator. So we'll just have y minus 1 there. And then minus, for this expression, the denominator, it's already y minus 2, y minus 1. So we'll just copy the numerator, which is just 1. And then in here, if we simplify, you'll just have y times y minus 1 minus 1. That becomes y minus 2. Denominator, you'll have y minus 2 times y minus 1. And now you can cancel y minus 2. So the final expression will just be y over y minus 1. So this is the final expression. Okay. Next here, we have y minus 1 over y minus 2 minus 1 over y squared minus 3y plus 2. So for this, again, start with factoring this denominator here, and then we try to find the LCD. So for the first, we have y minus 1 over y minus 2. For the second, we have 1 over, so y squared minus 3y plus 2, it's the same as the other guy here, y squared minus 3y plus 2. So we recall the factor y minus 2 and the factor y minus 1. And then LCD, it's just y minus 2 times y minus 1. Okay? And then for this expression here, the denominator, it's just y minus 2, but we need denominator y minus 2, y minus 1. So we have to multiply the numerator of this expression here by the missing factor in the denominator. So we'll have y minus 1 times y minus 1. And then for this, we have the denominator y minus 2, y minus 1. So again, we'll just copy the numerator for that expression. So we have here the minus 1. And then notice this is just y minus 1 quantity squared. So you can do your factoring difference of two squares. Or you can just expand this and then simplify the numerator. So if you do that, let's just expand this y minus 1 times y minus 1. That's equal to y squared minus 2y plus 1. And then we have minus 1 in here. And then we have here y minus 2, y minus 1 in the denominator. Okay. So this minus 1 and plus 1, they will just cancel each other. So what's left in the numerator? It's y squared minus 2y. Denominator, you have y minus 2 times y minus 1. And then you can factor out y in the numerator. So you'll just have y times y minus 2 over y minus 2 times y minus 1. And again, you can cancel y minus 2. And we'll be left with y over y minus 1. So this is the final expression. Okay, so let us move to our next problem here. Simplify expressing the final result with positive exponents only. Okay, so for this, we just apply laws of exponents. Okay, we can have, let me copy the expression. Oh, well, I'll just put some arrows here, so I don't have to copy. So from here, we have here this guy. Okay, we have here this guy. We also have here this expression here being cube, also this expression here being cube. So let us first distribute the exponent here, okay, and here over their respective groupings. Okay, so we will have in the numerator, we'll have negative 3a. So in here, negative 3 times positive 3, that becomes negative 9. And then we have b. For this, negative 2 times positive 3, that becomes negative 6. And then c, we have negative 1 times 3, that's negative 3. And then on the denominator here, we will have, so we distribute also. So 2 times negative 2 here, we will have 9 raised to negative 4. And then here you have a to the power 2, and then here 2. So you will have a raised to 4. And then b here, we have 3 and 2 here, so b raised to 6. And then c, we have here negative 3 and 2, that's negative 6. Okay? And then we have this. We can distribute this. We will have negative 3 raised to negative 9. A raised to negative 9. B raised to negative 6. C raised to negative 3 divided by this 9 here. Okay? This 9 here, I'll write that as 3 squared. Okay? So this expression here, I'll write it as 3 squared raised to negative 4. So 9, that's equal to 3 squared. So 9 raised to negative 4, that will be equal to 3 squared raised to negative 4. And so in here, in the denominator here, I'll just write it as 3 raised to negative 8. And then I'll just copy the other guys here. a to the 4, b to the 6, c raised to negative 6. Okay? Now, for this, we have a negative expression. The exponent, it's an odd number. So we can just bring out the negative. Okay? So we will have here, um, so this guy here, it will be equal now to negative 3 raised to negative 9. Okay? So, if that's the case, we'll just have negative 3 raised to negative 9. Let me copy everything again. And then simplify later. No, what I can do is um, we'll apply the other laws of exponents immediately. So let's just bring everything first to the denominator. I mean to the numerator. From denominator to numerator. Okay? So we have 3 raised to negative 8 in here. If we bring it to the numerator, we'll have 3 raised to positive 8. And then we have a raised to negative 9. We bring this to numerator, we'll have a raised to negative 4. Then we have b raised to negative 6. For this guy here, if we bring to the numerator, again, it's b raised to negative 6. And then we have c raised to negative 3. This, if we bring to the numerator, it becomes c raised to positive 6. Therefore, let's apply the laws of exponents. Okay, we have negative 3. Here we have negative 9 and positive 8. So negative 9 minus 8, that's negative 1. And then we have a. Here we have negative 9 and negative 4. That's negative 13. Here we have negative 6 and negative 6. That's negative 12. And then for the exponent of c, we have negative 3 and 6 here. That's positive 3. Okay? So if we simplify everything, we now bring these two guys here to the denominator because they have um, negative exponents. We want positive exponents only. Also, this guy here has a negative exponent. So we also bring it down. So we will have, in the numerator, we'll just have negative c cubed. On the denominator, we'll have 3 to the 1, which is just 3. And then a to the 13 and b to the 12. So this is the last expression. Okay? So the loss that we used, we have here a raised to n raised to m. This is a raised to n m. We also have a to the n, a to the m. This is equal to a raised to n plus m. We also have a raised to negative n. This is 1 over a to the n. Or you have um, 1 over a to the negative n. This is a to the n. Okay? Let's go to our next problem here. Um, quantity 2 square root of x cube root of y all over 6x raised to negative 3 halves y raised to 7 thirds, everything being squared. So one of the tips that I gave when you have something like this combination of radicals and exponents, you write everything in exponent form, which means that this expression, you can write this as 2x raised to 1 half, y raised to 1/3, and then we have divided by 6x raised to negative 3 halves, y raised to 7/3, and then everything raised to power 2. It's easier to calculate um, the expression if you have exponents compared to having radicals. Okay? And then let's just simplify this. Let's simplify the expression inside the big parenthesis here before we do the squaring. So if you do that, you have 2 over 6. Okay? You have 2 over 6. That becomes 3. And then in here, I know that if I add the exponents, okay, I know that if I add the exponents of the variable, I will get positive numbers. I can immediately see that. So that's what I'm going to do. So what I'm saying is, this guy here, I'll bring it up. Because, well, if I add 1 half plus 3 half, that's positive number. So I'll bring that x raised to negative 3 halves from the denominator going to the numerator. So I will have here x raised to 1 half and then x raised to 3 halves. Okay? Similarly, this guy here, I will bring it down here. The reason is if I bring this down, I will have y raised to negative 1/3 in the denominator. But 7/3 minus 1/3, that's a positive number. Okay? So I won't have any trouble in uh, having negative exponents here immediately. Okay? So in here, I'll just get y raised to 3, y raised to 7/3, and then y raised to negative 1/3. Okay? And then everything is being squared. Okay? And then if we do the squaring, well, we add first the exponents. We apply first the laws of exponents. We'll have here 1 half plus 3 halves. That's 4 halves. That's equal to 2. So you have x squared in the numerator. On the denominator, you have 3. And then y raised to 7/3 minus 1/3. So 7 over 3 minus 1 over 3, that's 6 over 3. And therefore, I'll just get y raised to power 2. And then here, we square it. And then finally, we'll just have x to the 4 over 9y to the 4. So this is the final expression. So we want to solve the following equation by factoring. So 3x cubed plus 5x squared minus 2x equals 0. So you have to solve this by factoring. You don't do any other methods. Okay? So first, we have here, we can factor out x in this expression. Everything has x. Okay? This guy here has x, this guy here has x, this guy here has x. So we can factor out that x. And what remains inside is the expression 3x squared plus 5x minus 2 equals 0. And then we factor this guy here if it is factorable. Okay? It should be because um you see I asked you to do this by factoring, so it should be factorable. So I hope I did not uh, have any errors in typing the expression. So let us see. Again, we use the general way or the method of solving or factoring general quadratic expression. So you have your 3x squared plus 5x minus 2. Your a, this is equal to 3. B, this is equal to 5. C equals negative 2. What else? So we need small a, small b, such that the product small a, small b, it's equal to the product capital A, C, capital A, capital C, and the sum small a plus small b, this is capital B. So capital AC, that's just 6 or negative 6. Okay, so this is just negative 6. Then we have A here, we have B here, and then we want small a plus small b, that's equal to capital B. Let's write what capital B is. It's equal to 5. So for this, um, you can use 2 and 3 as a combination, but one of them must be negative. Okay? So you can try maybe negative 3 and then 2, but negative 3 plus 2, this is equal to negative 1, which is not the one we wanted. But let's write the correct pair here. It will be 6 and negative 1. So that if you add them, 6 minus 1, this is equal to 5. Which means 3x squared plus 5x minus 2. You can factor, or you can decompose 5x into um, plus 6x minus x. And then we have the minus 2 here. And then just like before, we group this. On the first group, we can factor out 3x. And then what remains inside, it's um, x plus 2. On the second group, we can factor out negative 1. So we'll just have minus. What remains inside is x plus 2. And as you can see, you can factor now x plus 2 in here. So that you will have 3x minus 1. And then you have your x plus 2. Which means, going back to our problem here, we'll just have x times 3x minus 1 times x plus 2 equals 0, which means we have here um, x equals 0, 3x minus 1 equals 0, x plus 2 equals 0, or that for this middle part here, we'll only get x equals 1/3. And then for this guy here, we get x equals negative 2. So the answers are this, this, and this. Okay? Questions? Next problem here, we need to solve 1 minus x over 1 plus x equals x squared minus 5 over x squared minus 1 plus 3 over x minus 1. Okay? Now, look at this. This guy here, okay? This guy here, you can um, factor that. So x squared minus 1, you can factor that into x minus 1, x plus 1. This guy here, it has x plus 1. This guy here, it has x minus 1. The LCD, it's x squared minus 1. Okay? So we use LCD method. We, of course, assume here, that x not equal to 1, x not equal to negative 1. Otherwise, denominator will be 0. Okay? So we have 1 minus x divided by 1 plus x. This is equal to x squared minus 5 over x squared minus 1 plus 3 over x minus 1. Then we multiply both sides of the equation by the LCD, which is x squared minus 1. And in here, again, we multiply by x squared minus 1. So what you multiply on the left-hand side must be multiplied on the right-hand side to retain the equality. So that's your multiplication property of equality. But then again, x squared minus 1, it's factored into this. So meaning, if we multiply this guy here on this x plus 1 here will cancel the x plus 1 there. So what will remain on the right-hand side is the product 1 minus x times x minus 1. Because x plus 1 um, is cancelled. Okay? On the right-hand side, this guy, we just distribute it over this sum. Okay? So again, this guy, we just distribute it over the sum. If we distribute this on this part, x minus 1 will be cancelled. So what will remain for that expression is this guy here, x squared minus 5. And then we have the plus 3. Now, if we distribute this over this, that's your plus 3 there. But the denominator has x minus 1. And x squared minus 1 is factored into x minus 1, x plus 1. Which means x minus 1 here will be cancelled. So, these 3 will be multiplied to x plus 1. Okay? And then we'll just simplify this and solve for x. For the left-hand side here, this guy here, this is the same as negative times x minus 1 times x minus 1. I just brought out the negative from this guy here. So that's why you have x minus 1 in this part here. And then on the other side, let's just um, distribute the 3 here over this sum here. So on the right hand side, we copy that x squared minus 5 and then distribute 3. So we have 3x plus 3. Then let's just continue solving. Okay, we multiply x minus 1, x minus 1. So we have negative quantity of x squared minus 2x plus 1. On the right hand side, let's just simplify this into x squared plus 3x minus 2. Okay, the left hand side, let's distribute this negative here over those expressions. We'll have negative x squared plus 2x minus 1. This is equal to x squared plus 3x minus 2. And then we put everything on the other side of the equation. I mean on one side of the equation and then 0 on the other side. So maybe let's put all of this on that side. Let's put the expression on the left hand side to the right hand side. So we'll just have 0 in here. And then when this guy here moves to the right hand side, it becomes plus x squared. And we still have the x squared here. So we'll get 2x squared. Here, if we bring this to the other side, it becomes minus 2x. And we have 3x there. So 3x minus 2x will only get x. And then this guy here, if we bring it to the other side, it becomes plus 1. So we'll just have um, minus 2 plus 1. That's minus 1. Okay? And from here, you can use any method you want. Okay? But for this guy, but for my solution that I'll present here, it's still factoring. This guy here, we can factor this into 2x minus 1 x plus 1. And that's equal now to 0. Okay? Or we will have 2x minus 1 equals 0. Or you have here x plus 1 equals 0. So for the first one here, we have 1, or we have x equals 1 over 2. The other guy, this is x equals negative 1. But this guy here, take note, x equals negative 1, but we don't want x equals negative 1. So for this guy, I'm not sure if you are familiar with the term. I have not used this uh, before in this course. So this guy here, this is an extraneous solution. So we cannot use that. Okay. So in here, we only have x equals 1/2 as a solution. Okay. So for this type of problem, if there are solutions which should not be there, you have to specify it. You can just write this cannot be a solution, so the only solutions are these, or you can just write this is an extraneous solution, and then it's um, it's automatic that I know that you know it should not be there. Okay. So this solution here, we have used LCD method. Any questions? Let's have another. So x plus 1 over 1 minus x equals x squared plus 1 over x squared minus 1 plus 1 over x plus 1. Very much similar to the previous problem. So again, this guy here, we have 1 minus x. This guy here, you have x squared minus 1. This guy here, you have x plus 1. So take note, 1 minus x, this is negative of x minus 1. And again, you have your x squared minus 1. It can be factored into x minus 1, x plus 1. So if we use LCD method again, we multiply both sides of the equation by x squared minus 1. Okay? So on the left-hand side, you have x plus 1 over 1 minus x. We multiply this by x squared minus 1. On the right-hand side, we have x squared plus 1 divided by x squared minus 1 plus 1 over x plus 1. We multiply this by x squared minus 1 to retain the equality. And then just like before, this guy here, it's factored into this. So if we multiply this guy here over here, okay, we will be able to cancel x minus 1, but take note, a negative should come out. 1 minus x, it's negative x minus 1. So a negative should come out. Therefore, on the left-hand side, we will have negative x plus 1. So it means we were able to cancel this x minus 1 here, but we still have the x plus 1. So this is here multiplied to x plus 1 equals. Again, we distribute this here and here. So if we do that, in the first addend, we'll just have x squared plus 1 because this guy here will totally cancel this. Plus, this guy here will be able to cancel the x plus 1, but there will be x minus 1. And multiply it to 1 in here, we'll just have here x minus 1. And then let's just simplify everything here. On the left-hand side, we have negative. Expand x plus 1 times x plus 1. That's x squared plus 2x plus 1. On the right-hand side, we'll just have x squared plus x. 1 and minus 1 will cancel each other. And then what? Distribute the negative here. We have minus x squared minus 2x minus 1. On the right-hand side, let's just copy it, x squared plus x. This guy, we bring it to the right-hand side. Okay, everything becomes plus. Okay, so we'll just have 0 equals. And then we have this x squared. This guy, when brought to the other side, again, it becomes plus. So we'll just have 2x squared. This guy here, we bring it to the other side, it becomes plus 2x. So we will have plus 3x in here. And then this guy here, we bring it to the other side, it becomes plus 1. Okay? So here, again, you can use any method to solve this quadratic equation. But the solution I will show, it's still by factoring. 2x squared plus 3x plus 1, you can factor that into 2x plus 1, x plus 1. And this guy here is equal to 0. Okay? And then, therefore, you will have 2x plus 1 equals 0, or um, x plus 1 equals 0. Going back to the original expression here, okay, our restriction is that 1 minus x cannot be 0, x plus 1 cannot be 0. Okay? Or x cannot be 1, x cannot be negative 1. Now, on this last line here, we have this guy here, x plus 1 equals 0. But again, x plus 1 cannot be 0. So this guy here, this will give extraneous solution. Will give extraneous solution. While for this guy here, let's just calculate. It's x equals negative 1/2. So this is our final answer. Okay? Questions? Next, solve the system by elimination method. Okay? So, elimination method, we eliminate one of the variables and then solve for the other variable. That's the elimination method. And in the solution that I will show, I will do the full elimination method. Okay? To solve for x, I'll do the elimination method. Also, to solve for y, I'll do the elimination method. Okay? There is a combination of elimination method and substitution method. You can solve for x by elimination method, and then to solve for y, you do substitution because you were able to solve for x already. So that's the combination. Okay? But like I said, I will do the uh, full elimination method here. So how is that? So you have here 3x plus 7y equals negative 1. 2x minus 5y, this is equal to 9. So equation 1 here, equation 2 here. So I'll solve for x first. Okay? So solving for x. Solving for x. So for the first, I'll multiply equation 1 by 5. And then I'll multiply equation 2 by 7. Equation 1, okay? We have 5. This will give us what? 15x plus 35y equals minus 5. And then for equation 2, we multiply by 7. We'll have 14x minus 35y equals 63. And then we add them together. If we add them, we'll have here 29x. This is equal to negative 5 plus 63. That's 58. And then we solve for x. This is 58 over 29. 58 over 29, that's equal to 2. So this is our x. On this side, we solve for y. To do this, we'll multiply the first equation by 2. And then the second equation, let's multiply negative 3. For the first equation, we'll have 6x plus 14y. This is equal to negative 2. For the second equation, we'll have negative 6x plus 15y equals 27. This is negative 27. So if we add them, 6x minus 6x, they will cancel. We'll just have 29y. And then on the other side, we have negative 29, which means y equals, let's write this, negative 29 over 29. This is negative 1. So this is the value for y. Okay? Questions? Let's have this problem. The base of a triangle is 10 meters less than 3 times its height. Find the base and the height of the triangle if its area is 24 meters squared. And hint, the area, it's just base times height over 2. Okay? So let us introduce the variables first. Let h be the height. Okay? And then let b be the base. Then it says base is 10 meters less than 3 times its height. So base is 10 meters less than 3 times the height. Okay? So again, the base is 10 meters less than 3 times its height. Okay? So this is your base. Okay? In terms of your height. The area, it's 24 meters squared. So we will have the following. So we have 24. This is 1/2 base times height. So this is 1/2 base, it's 3h minus 10. And height, it's just h. Okay? Or we will have 24 times 2. So we multiply both sides of the equation by 2. We'll have 48. This is equal to this expression. Let us just multiply them. It's just 3h squared minus 10h. So in here, we have 3h squared minus 10h plus minus 48 equals 0. So we bring this to the other side of the equation, it becomes minus. And then we use symmetric property. So that will bring 0 to the right-hand side. Okay? Now, again for this, you can use any method. Since we've been using factoring, let me use here quadratic formula. Okay? By quadratic formula, h equals, okay? So by quadratic formula, h equals negative b, so that's 10, plus or minus square root of b squared, negative 10 squared minus 4 times a, which is 3, times c, which is negative 48, all over 2a. So 2 times 3. So here we'll have 10 plus or minus square root of negative 10 squared, that's 100. And then we have minus here, and there's a minus here. So this becomes plus. And then you have 4 times 3 times 48. 4 times 3 times 48. We'll have 576. And then on the denominator, we will have 6 in here. Okay? And then 100 plus 576. We have there 676. And this guy here, we get the square root. Okay? The square root of 676. I hope that's just good one. It's an integer. We're good. So we have here divided by 6. We now have 10 plus or minus square root of 676. It's equal to 26. Then divided by 6 in here. So here you have 10 plus 26. That's 36 over 6. Or you have 10 minus 26. That's negative 16 over 6. We are talking about height in here. This guy here, this is negative. This is extraneous solution. Okay? So let me just write it here. This is extraneous solution. And then we now write the conclusion. Well, 36 over 6, that's just 6. So the height is 6 meters. Take note of that. We are using meters. And the base is so 3 times 6 minus 10. This is equal to 8 meters. So this is the final answer. That's the conclusion. Okay?